Hello students, welcome to another video for class 8. We are dealing with the chapter light, and one important part of this chapter is about spherical mirrors. So today you will be learning what is a spherical mirror, its types and how images formed in them. So let us begin. Before discussing about spherical mirror, children, if you have a steel spoon at your house, you should go get it and try to see yourself in that mirror. There are two sides of the spoon. One is a concave side and one is a convex side. So if I talk about a spherical mirror, it is a smooth and highly polished curved glass surface which is a part of a hollow sphere where one side is made reflecting and other is opaque. So we can basically classify them into two parts, that is concave and convex. If you see the diagram, you will understand that the concave part is silvered in the bulging side and reflecting in the inner side, and the convex one is the reflecting part is the bulging part, whereas it is silvered in the hollow part. The concave mirror is a spherical mirror, you can say, which is polished from outside, and so the inner hollow surface of the spherical mirror is acting as a reflecting surface, whereas the spherical mirror whose inner hollow surface is polished, this side is hollow side which is polished, and it is made opaque so that the outer surface is reflecting, that is a convex mirror. Now there are some terms that we need to learn about spherical mirrors. The first term is aperture. The surface of the spherical mirror which is exposed to the light for reflection is the aperture. Then we have the pole. It is the geometrical center of the spherical mirror, we can say. And then we have the center of curvature. As I told you, the spherical mirror is a part of a hollow sphere. So the center of the hollow sphere, at which the mirror forms a part of, that is the center of curvature. The radius will be the radius of the hollow sphere of which the mirror is a part of, and the principal axis is the straight line which is joining the pole and the center of curvature of a spherical mirror. Now if you see this diagram, if suppose this is a sphere, I know it doesn't look like exactly a mirror, but if this is a concave mirror, this is a polished side and this is a reflecting side, and if this is a whole sphere, this is the center of curvature denoted by C. This is the pole which is a geometric center, and the difference or the distance between the center of curvature and the pole is forming the radius of the hollow sphere. Now focus or the focal point. It is a point on the principal axis at which the rays incident on the mirror parallel to the principal axis actually meet after reflection in case of concave mirror. In concave mirror, the rays are actually going to meet, and they appear to meet after reflection in case of the convex mirror. So if I show you, if this is the center of curvature and this is a concave mirror, the rays which are parallel to each other, which are striking this reflecting surface, they will all seem to pass from a particular point which is the focus. This part is a focus. It is actually meeting in case of concave mirror. But in case of convex mirror, because this will be the opaque side, this will be a reflecting side, so the rays which are coming parallel, they are actually going to diverge or reflect outside, but all will seem to be coming from one particular point which we call the focus of the spherical mirror or the focal point. Now next we have the focal length, which is the distance between the pole and the focus. So now if this is a pole, all of you know, and the distance between the pole and the focus is known as a focal point. So here this distance, the pole and the focus, the distance between them is the focal length, which is generally half of the radius. So if you see this, radius by 2 will give you the focal length of the mirror. Now, we are going to learn to draw the ray diagrams. Ray diagrams are the way of representation of how the image of an object is going to look in a concave and a convex mirror, or a spherical mirror in short. So there are certain rules that you need to remember. Firstly, to draw a ray diagram, we will take only 2 rays for convenience, and they should start from the same point, and then we are going to show how it is being reflected. And this is done for simplicity. There are many rays coming out, but we can't draw all as it will become messy. Always keep the object on the left side or in the front of the reflecting surface. The object has to be placed in front of the mirror. Always place the object vertically upright. So suppose you can see this pen. This is a vertically upright position of the pen. And you will see at times after reflection, the image appears upside down. Now, there are more rules that are applied when the rays are going to emerge and reflect. The first one is a ray passing through the center of curvature. What is going to happen in case of concave mirror and in case of convex mirror? The ray which is passing through the center of curvature will fall on the reflecting surface normally and hence retrace the path after reflection. For concave mirror, as you can see here, I have drawn the ray which is coming and passing through the center of curvature. It is falling on the mirror and it is retracing its path back. So you can see this is a coming ray and this is a going ray, and it is the same path through which it had come. Same for the convex mirror. The ray will appear to pass through the center of curvature and retrace the path after reflection. The ray which appears to be passing through the center of curvature falls on the reflective surface normally and hence retraces the path. So I have shown you the arrow showing that it is retracing the path. Here it is shown with dotted line because actually the ray is not going to come here. It is appearing to meet here or passing through the center of curvature in case of convex mirror. The second is when a ray parallel to the principal axis is there, then what happens to it after reflection? So you can see a ray which is parallel to the principal axis. This is the line, imaginary line touching the pole, focus and the center of curvature, which is called the principal axis. And when it is coming parallel to the principal axis, it passes through the focus in case of a concave mirror. So you can say that a ray of light parallel to the principal axis after reflection from a concave mirror will pass through the focus. You have to keep these points while drawing the ray diagrams for any given condition. And in case of the convex mirror, we can say that the ray of light parallel to the principal axis after reflection from a convex mirror will diverge and appear to come from the focus. So actually, if this is the ray which is coming, it's diverging, but it seems to come from this point, which is the focus. This is in case of convex mirror. The third will be when a ray is passing through the focus. So as you can see the diagram, the ray is passing from the focus and falling on the reflecting surface of the concave mirror. So it will appear to be becoming parallel to the principal axis. And here as well, as it is coming and it's becoming parallel, but it feels as if it has come from the focus. So we can say that a ray of light passing through the focus after reflection from the concave mirror will travel parallel to the principal axis, whereas a ray of light which appears to be passing through the focus of the convex mirror after reflection will travel to the parallel to the principal axis, as you can see here in this diagram. In the fourth condition, a ray is incident at the pole. So you can see in the diagram for concave and convex mirror that the ray is focusing on the pole for both of these given condition. So in a concave mirror, we can say that a ray of light incident at the pole of a concave mirror will get reflected at the same angle as per the law of reflection, that is angle I. Incident ray is equal to angle of reflection. And similarly, for a ray of light incident at the pole of a convex mirror will get reflected at the same angle, again based on the principle of or the law of reflection. Now, using this laws, we are going to show you an example of how the ray diagram is actually formed. Suppose the question says that the object is between the center of curvature and the focus. So how are we going to represent it? Now, according to the given condition, the object is between the center of curvature and the focus. Now, just remember that when you draw the mirror, this is a concave mirror, okay? And try to make this principal axis, and if you have taken like 3 cm for focus, take the double of it for center of curvature. Like the difference between these two should be same. The part of P to F, because this is a pole, suppose here it is 3 cm, I have taken F to C also 3 cm. This is important to get the proper result. According to the question, I have placed the object between the center of curvature and the focus. Now, using the principles that I told, we are going to take 2 rays for simplicity. One I will be drawing parallel to the principal axis. So, if this is the head of the object, I take a line which is parallel to the principal axis. And you know that when a line is parallel to the principal axis, it will pass through the focus. So, I will draw it in such a way that it passes from the focus. We don't know where it's going. Okay. Now, another ray we will take, which we will pass, and it will seem to be coming from the center of curvature. And then when I meet these 2 lines, you can see that it is meeting at a certain point. So, I am just extending my line. Wherever these 2 lines are meeting, I shall be drawing, which is actually inverted, because according to the condition here, the image formed will be, you can see it is larger in size, so we can say it's magnified, it is inverted, and also it is real as it is inverted. So with this, I am sure you can try some by yourself, and let me know in the comment section whether you are able to draw the ray diagrams based on the different rules that I have shared with you. Thank you for watching.